Hi and welcome to Cherry Pie Math. This video is going to go over testing proportional relationships, or really just looking at information and then trying to see if there's a proportional relationship out of it. So what you should know before we get started, first you need to know what a ratio is. You also need to know how an XY chart is formatted, and then an XY coordinate grid. So like this is the X, or this is the Y axis and this is the X axis, for example. If you know those things, you should be good to go. All right, so first, you've probably used Word before, like Microsoft Word, and you want to make a picture bigger. Which one would you press and drag to make it bigger if you had a picture in there? So hopefully you know that you pick like one of these four corner ones. And we would choose them because when you press it and you drag it outwards, it maintains the scale. Whereas if you drag one of these ones in the middle, it'll warp it because it only changes it like one direction. So the height doesn't change, but the width changes, for example, and that just skews up the whole picture. And I used to do it for my students, and they would freak out and be like, no, stop. So we would keep one of the corner ones to make sure that the scale or the proportions stay the same. So we've heard this word before probably in our lives, proportion. What is a proportional relationship? It's when two quantities have a ratio in common. And remember that a ratio is like a multiplicative or a division relationship. So that basically it's saying you can multiply one of the quantities by a certain number, and that'll give you the other quantity, and vice versa. So to determine if there's a proportional relationship, we divide the proportions and compare them to make sure that they're the same. They need to have the same ratio. Otherwise, if they don't have the same ratio, it's not going to work. And to get that ratio, all we're really going to do is divide one thing by another. And usually, and this will make more sense as you go in mathematics more, we usually do the second column divided by the first column. It kind of matters and it kind of doesn't. Sometimes it doesn't matter as much. But because usually when we set this up, when we have X and Y, we usually do Y divided by X, because this is the dependent divided by the independent variable. And that's a whole other lesson. But for now, we really just are going to do this divided by this and make sure that it stays the same. Actually, because we're doing just proportions, we're not looking at really anything else. You could do it the other way as well, but we're not going to. Okay, so let's do an example. Let's say we have the amount of minutes and we have the number of laps. So we are going to check to make sure that this is a proportional relationship. And the way we would do that is we would do 0 divided by 1, 2 divided by 2, and 3 divided by 3. Like I said, we're just doing this number divided by this number divided by this number, and this number divided by that number. So this first one is equal to 0, this one's equal to 1, and this one is equal to 1. These are not the same, so it is not proportional. Because these ratios do not match. And that's really all it is. To test if something has a proportional relationship, you divide them all and you double check. You can also check by doing these, like one of these divided by one of these. There's a couple of different ways you can set up the proportion. But for the sake of keeping it simple, we're always just going to do the second column divided by the first column if we have an XY table. So let's do another one. We have 5 divided by 2, 10 divided by 4, and 15 divided by 6. So this one is going to be 2.5. This one is going to be 2.5. And this one is going to be 2.5. Oh, look at that. It's so cool. It is all the same. So this is proportional. So you could do it in that, or you could actually make it into fractions as well. So 5 divided by 2. The second one is 10 over 4, which if you divide out the 2 becomes 5 over 2 again, and 15 over 6, same thing, is equal to 5 over 2. So we can tell that this is proportional because when we divided them, we got the same ratio. Remember, the ratio is just a fraction. So let's do another example. Let's say I have batches and cups of sugar. So I would do 0.5 divided by 1. I'd have 2.5 divided by 5 and 3.5 divided by 7. And again, if you plug this into a calculator or you do it by hand, either way you get it, you should get 0.5 for all of them, which says yes, they are proportional because their ratio is the same. All right, let's do one more. Let's say age and height. And you can probably guess that this one is not going to be proportional because when you're growing at 6 years old versus when you're growing at like 12, or you're hitting puberty, you just shoot up like a beanstalk, right? So let's see, we have 29 divided by 1, 40 divided by 4, and 54 divided by 9. So this is 29, this is 10, and this is 6. It's obviously not proportional because they do not maintain the same ratio. There's also some graphs that you might see just to see if they are proportional. First off, all proportional things are going to be linear because you can only change one thing at a time. But the other thing that matters is that it has to go through a point that we call the origin. The origin is 0, 0. That's right here. So if the line doesn't go through 0, 0, then it is not proportional. So this one, yes to the origin. So this is yes proportional. But the other one, yes, it is a line, but it doesn't go through the origin, which is down here, so it is not proportional. And that's really the biggest thing here, is that if it's a graph, it needs to make sure that the line goes through 0, 0. It could be downwards, like if I have a graph like this, right, and my line goes downwards like that, as long as it goes through that center point, it's okay. But it has to be a line and it has to go through the origin. So the biggest giveaway here is that it needs to have a constant of proportionality, which is really just a fancy word for ratios. There needs to be a ratio between your two values, your two quantities, that stays the same. If that constant of proportionality changes at any point, the relationship is no longer proportional. So some things to remember: if it's proportional, it will work from x to y and from x to x and from y to y. Kind of like I said, you could technically switch it up. For the sake of today, we're really just doing y divided by x, but proportionality could be determined the other way as well. On a graph, it's a line that goes to the origin. It has to go through 0, 0. Constant of proportionality is a fancy word for the ratio in the proportion. And then tables help us organize the info to see if it's proportional. Yes, it is easier to see right away if it is proportional by looking at a graph, but I really like tables, especially when you do word problems, just because it helps you to organize the information into a chart, and then you can just do a little bit of math to double check if it's proportional or not. Anyway, I hope that helps, and good luck with everything.